You type an address into your browser, hit enter, and the page appears. It's a mundane action you do dozens of times a day. But if we freeze time in that fraction of a second before the page actually loads, a complex mechanical journey is taking place. To understand this journey, we have to look at the two sides of the conversation. Think of your web browser as a hungry customer at a restaurant, placing an order for specific information. In the world of networking, we call this role the client. This diagram shows the relationship between that client and the kitchen, the server. The server is a powerful, remote computer sitting somewhere else in the world that holds the text, images, and videos your browser is asking for. But there is an immediate hurdle. Your browser knows the human-friendly name of the website, like google.com. The internet's hardware, however, only knows how to find things using long strings of numbers, called IP addresses. Before your requested page can even begin to load, the network has to translate our human language into those exact machine coordinates. This graphic shows how DNS works like your smartphone's contacts. You tap a friend's name and it finds their dialing number. Below, your device asks a DNS server, "Where does this domain live?" The server finds and hands back the exact IP address, 93.184.216.34. Now that your browser knows exactly which computer to talk to, it packages up your request to be shipped across the globe. This diagram tracks the physical journey of that package. Following the dashed blue line, your request bounces through a series of hardware routers. It jumps through miles of fiber optic cables, crossing cities and oceans, until it reaches the target web server. Every click triggers a physical relay race through real hardware and cables, connecting your local machine to one specific building. Once your request arrives at that server building, it needs a way to get inside. Each specific entry point has its own number, which we call a port. This contrasts your browser's entry doors. Left is port 80, open, HTTP. Sending plain text allows hackers to read your passwords. Right is port 443, secured, HTTPS. It works like a locked door, using cryptographic keys to scramble your conversation into unreadable gibberish. Safe inside the server via that secure port, your request is processed. The server locates the specific files you ask for and immediately fires them back to your computer along the exact same physical route. These port numbers dictate the security of your connection, keeping your personal details scrambled and private as they travel home to you. When that response finally arrives back at your screen, it doesn't look like a finished painted picture. Instead, the server sends a raw text blueprint called an HTML file. This chart maps the HTML blueprint. DOCTYPE and HTML tags act as an outer wrapper, laying down structural rules. The blue head contains invisible data, while the orange body holds visible content. Tags must operate in pairs. Forgetting the closing slash breaks the visual layout. HTML is a logical, nested outline. It gives your browser the raw instructions it needs to construct the final experience. Your browser reads this text blueprint at lightning speed, instantly rendering the colors, snapping the text into place, and stacking the images onto your screen. This final diagram ties the entire journey together, from typing the address and checking DNS, jumping through physical routers, passing through secure port 443, and finally back to your browser for rendering. What looks like an instant result is actually millions of perfectly coordinated, secure conversations between machines, finishing in less time than it takes to blink.